Haptic authentication, one touch authentication for blind and low vision users to mitigate shoulder surfing attacks. There is no doubt that the emergence of accessibility features have helped the lives of blind and low vision users. But they have also put these users into a lot of troubles when they try to authenticate their smartphones because the system would read out their user's PIN and this could lead to eavesdropping. Accessibility features like voiceover from Apple and talkback from Google, and also the magnification accessibility features, have raised concerns of shoulder surfing attacks as people with vision impairment often use these features and have concerns about being vulnerable to shoulder surfing attacks or observational attacks. One of the contextual inquiries with vision impaired people showed that even though users used many of the accessibility features, but they did not prefer to protect their phones with any kind of pins or passwords. To resolve this issue of shoulder surfing attacks or observational attacks while maintaining the usage of PIN entry for authenticating the devices, I plan to implement a novel authentication method which is based on haptics for smartphones that uses one key on the screen for PIN code entry. Users will be presented with haptic patterns that allow them to determine the numbers and proceed with the PIN entry on their screen. Haptic patterns are used due to their ability to present information to the user in a private manner, since the haptic sensation is typically felt only by the user of the device. Therefore, this research focuses on contributing on the following factors like you can see on the screen. Researchers have been working on understanding assistive technology and how visually impaired users interact with these technologies. And there have been researches that focuses on current authentication technology as well as developing new authentication technologies for visually impaired users. Current authentication mechanisms pose significant challenges for people with visual impairments. This paper presents results from a contextual inquiry study that investigated the experiences this population encounters when logging into their computers, smartphones, and websites that they use. By triangulating results from observational, contextual inquiry interviews, and hierarchical task analysis of participants' authentication tasks, they found that these users experience various difficulties associated with the limitations of assistive technologies, suffer noticeable delays in authentication, and fall prey to confusing login challenges. The hierarchical task analysis uncovered challenging and time consuming steps in the authentication process that participants performed. This study raises awareness of these difficulties and reveals the limitations of current authentication experiences to the security community. They also discuss the implications for designing accessible authentication experiences for people with visual impairments. This paper provides an evaluation of the single tap braille keyboard designed to assist people with no or low vision in using touchscreen smartphones. This application allows blind users to input characters based on braille patterns. To assess single tap braille, this study compares its performance with that of the commonly used QWERTY keyboard. They conducted an evaluation study with 7 blind participants to examine the performance of both keyboards and on Android platforms. Overall, participants were able to quickly adjust to tab braille and type on touchscreen devices using their knowledge of braille patterns within 15 to 20 minutes of introduction to the system. The single tap braille keyboard was better than the QWERTY keyboard in terms of both speed and accuracy, indicating that single tap braille represents an improvement over existing alternatives in making touchscreen keyboards more accessible for blind users. Based on the evaluation results and the feedback of their participants, they discussed the strengths and weaknesses of previous keyboards that have been used by participants as well as those of single tap braille. In doing so, they consider possible design improvements for the future development of accessible keyboards for blind users. We created a low fidelity prototype on Figma for our reference to decide on which features should be available in our final prototype, and our final app has more or less the same features. The methodology we follow for this app includes an informed consent along with a background questionnaire in the beginning. Then we allow the users to change the settings that include the change of vibration duration and interval, after which the user can practice with the chosen duration and interval. Then, for 7 consecutive days, the user will receive notifications to perform diary studies, which consist of performing login methods in 3 different conditions, and then they will be redirected to fill out a survey. After 7 days of study, we request the users to fill out a questionnaire that inquires about the best conditions and methods. In this video demonstration, we show how the structure of the app look like and how the user can change settings of the vibration duration and the vibration interval as well. The questionnaires after performing the diary studies are also shown in this video. We plan to evaluate this authentication mechanisms in the following ways. We will recruit participants via email. We will have one virtual session on Zoom which will explain the authentication mechanism and the study procedures to the users. We will also be collecting the data like accuracy and the time consumed to authenticate the system via Android Studio. The session will take about 10 to 20 minutes to cover each condition and answer the questionnaires. I would like to thank you all to listen to this presentation, and I hope all of you like this video. If you have any feedback, you can reach out to me via email or my courses. Thank you so much.